Yeah, very good evening. Good evening. So today a little bit link problem is there. Okay. So let's start the session here. How are you? Okay. Have you practiced certain matplotlib libraries as well? Have you practiced with the matplotlib library? Students, can you hear me well now? Have you did certain matplotlib library practice also? Okay. Thank you. So let's go ahead with a new library now. And that one is a Seaborn. So today I'm going to take a Seaborn. So basically, Seaborn is one of the library which is based on matplotlib. Matplotlib library works for two-dimensional data, but Seaborn library, which is built on the top of matplotlib, that can work for the three-dimension also. Two dimensions here, I can say it is working for the X and Y, means two variables. In Seaborn, we can have an option that can be working with the three variables as well. So let's go and explore the Seaborn library here. This is very useful library. So basically, when we talk about the Seaborn library, just wait here. Okay, you can see here, Seaborn is a Python data visualization library that is based on matplotlib. It provides a high-level interface drawing attractive and informative statistical graphics. Seaborn helps you explore and understand your data. Its plotting functions operate on data frames and NumPy arrays containing whole data sets and internally perform the necessary semantic mapping. And also it will give the statistical information, statistical aggregation to produce the informative plots. So here, let's go ahead with the Seaborn library. So there are a few functions. So let's see how to write the Seaborn library here. First of all, just to call the Seaborn library, I can call here import Seaborn as SNS. That I can do it here. So just wait. Seaborn library. That one is a data visualization library. So you can give your heading on your own as a data visualization library here. Okay. If you want to call a Seaborn, simply you will be writing here Seaborn as SNS. Now, because Seaborn is going to take certain variables that are working onto the data frame, so I need to call pandas. Seaborn can also take the NumPy array. So here I can just call import NumPy as MP. NumPy as MP. Now, certain time what happened, there are so many methods of Seaborn. Because every time there are certain version changes also, so there may be a possibility there is a little bit manipulation into the name of the functions also. For that, there could be certain warnings. So I want to suppress the warning. So just to suppress the warning, I'm going to give warning dot warnings dot filter warning. I want to make the filtration of the warnings here. This one is the warning actually. I want to make the filtration of the warning, and that one is a ignore. It means I'm saying that due to the version changes, because every time the new versions are coming, a little bit, a small change into the spelling of the functions is coming here. So it start raising certain, I can say it start raising certain warnings, pink lines here. Warnings will be started coming. So I want to suppress those warnings. So simply here I'm writing import warnings, and if certain warnings are coming just due to the version changes only, so just to ignore that. Rest is okay here. Okay. Okay. So I had imported a Seaborn, pandas, numpy, and just want to suppress the warnings as well. So here it is just showing you sub import warning, warnings.filter warning, ignore. So still it is just making the processing here. In the meantime, what I can do, let me prepare some data, and then I will be using a Seaborn library SNS. So there are various methods of the Seaborn library. Let me use that one. So here I'm just calling. Here I'm just calling, just wait. I'm writing here, A is equal to, here I can make the list directly now. Okay, let me make a list here. Any data here I'm writing. Suppose I'm writing some data here I'm writing. Let's take a data and random data here. I'm just making it here. Now I need to call the Seaborn library here. So simply I will write here. There is one of the methods Seaborn SNS dot strip plot. There is a strip plot method. Inside the strip plot method here, I can just give these two data. Let me see the plotting. So here it is just making certain plots. Some data here it is making, okay? Because here I just giving a random data into the Seaborn data visualization library. So here it is just giving like for January, these number of days are there. For February, these number of days are there. March, these number of days. And for April, these number of days. The point is here I want to use a Seaborn strip plot library, strip plot method here. So the point is here, basically in Seaborn, there's a lot of method here. So one by one, we are going to explore them. Just a moment. Okay, so let's see here. Now what I do here, I'm going to take various method here. There is one of the methods strip plot here. So basically now, when I will be using, there's a lot of method. I will be using those method. So here, if I'm using a Seaborn, there are certain method such as strip plot method, violent plot method, count plot method here. So these are basically methods: strip plot, violent plot, count plot, swarm plot. So I'm going to use this method here. So let's see how we can use that. Okay. Fine. So first of all, I need to call one of the wait here. I need to call one of the CSV file here, CSV. So let me check it out, the CSV file which can be called, which is having the data as well. So here I would be calling one of the file such as emptest.csv. So let me call this file here. I had already called the panda. So here I'm writing df is equal to pt.read csv. And here I'm going to call emptest.csv file. Here I'm going to call the df. So inside the df, some data are given there. I just call this file. Now, when I'm calling this file, now I want to make certain graph based on this this data. Okay. So I can take any integer data. So what I can do, wait here. If I want to make a Boolean plot, so what values I can give it inside the Boolean plot here? I need to check some signal. Sorry, this one is a Seaborn actually. Wait. Okay. Here, I will be taking one of the variable as a x. Inside the x, I'm going to take this age because I want to plot this age. So here I'm going to give this age. Now, if I directly gave it, I need to make this Boolean plot understand that from where the data source is. So I have to tell where is the data source. The data means give me the data source as well. So here data is equal to, I need to give this df also, this df, because inside the df entire data is there. Or what I'll do for your easy, wait, I'm changing the name of data frame for your easiness. So wait, I'm writing here empts, just for your comfortable, I'm doing it. Employee data set. So here I'm going to change it as the employee data set. So now it is comfortable now. Okay, so employee DS is there. Now I need this employee DS here. Means here, this employee DS, which I'm working with it here, I need to call it here. Employee DS. So here I'm just stating that this employee data set, I'm going to call here into the data. Basically, data is equal to employee data set here. Okay. So it means I have to choose a variable or column name to which I want to make a Boolean plot. And also I have to give the data source. So employee DS is the data source here. So that I'm going to give it here. So here it is just making a employee DS visualization here it is making for the age. What should I understand with this data? What should I interpret this data? Basically, it is just showing. You can see here. See this point. From this data, it is just showing me that maximum number of the people which are given in this data are at the age of 35. Means here they are a little bit up or down with the age of 35. So average age is 35 and rest are a little bit up and down for the age 35 is there. So maximum numbers who are employed, they are at the age of 35. This one is the revelation of this data from employee data set. Suppose I want to understand this salary. Salary is given here. I want to make a Boolean plot of the salary. What should I give it? I will be taking the same column. Oh, wait, I will be taking the same column name. There should be no spelling mistake. And then here, when I'm giving the Boolean plot here, so here I'm going to write Cbond dot Boolean plot. And here I'm going to give X is equal to salary. So I'm just saying, okay, just plot for the data Boolean plot for the salary. And here we have to give, where is the data source? So inside the data source, I have to give empts. See the difference. So here it is just giving you that how the data this volume plot is what this volume plot is showing to you. So here it is showing you, you have to follow on the fattiness of this volume plot. So it is just showing to you that basically salary from the above CSV file that shows the like majority of the people are getting a salary on an average for $5,000. So nearby. So here it is just saying that one is on an average salary. So basically here it is just showing you the people, mostly the people are into this bracket, 5,000 bracket, 5,000 little bit up, little bit down bracket here. So from the volume plot, we are getting that where is the maximum people coverage are going related with the age as per this data set, employee test data set. Got the point here? And as per the salaries as well. So this information, this volume plot is giving us. Seaborn, pandas, matplotlib, these are all Python libraries. We are giving salary here. Now we are giving here salary because here into the means here we have inside this X now. I have to give one of the column here. One of the column here I'm giving X. If you give here Y, suppose you are saying that suppose you want to give here Y, so Y will be coming this side here. That is not a suitable one. That is not a right one. In this way, you will be getting Y na Y is there. So into the vertical mode, in this way it here is getting. But just give us X1 as a suggestible. Give X1. Okay, so this one is a volume plot. Now there are other plots as well. Okay, in Seaborn there are other plots as well. So let's see and explore the other plots as well here. So there are certain category plot basically. Inside the category plot means here one, I can take the two variable. One variable here I can see as a, you can say like one variable I can take it as an integer and the another variable I can take it as a string data. Means one variable X as a integer data and the another variable I can take it as a categorical data. So there are certain category plot where I can build up a strip plot, storm plot, count plot, cat plot. Okay, four plots are there. Now here, for making this strip plot, storm plot, count plot, and cat plot, let me take some data set. So let me explain this data set first. What is this iris flower data set about here? Okay. First of all, are you aware with the iris flower data set? Any idea? Have you heard about the iris flower a little bit? If not, okay, let me tell you. This data set is very popular. Iris flower data set is very popular among the data science and machine learning because this data set have a very good information. Nearby 1950s, means 50 years, 70 years back, some scientist has created this data set. He is related with a certain horticulture department, means flower department, you can say it in simple. Okay. So basically iris the flower, it has number of species. Some are big flowers, some are medium flowers, some are small flowers. So here, when we talk about the iris flower data set, Here, the scientist picked 150 flowers. Let me tell you the history, how this data set is created basically. There's a scientist. He collected 150 flowers. And all the species belongs to iris. So basically, some flowers are having bigger sunflowers are having lengthier leaf. So that data scientist started making the measurement of this lengthy leaf and width of this leaf. And he also made a measurement of this length and this width also. So he collected this 150 flower and started making these measurements. Okay. So let me tell you here, he took the measurement of these leaves basically and started making a table. So these measurements are being taken for four variables, four columns here: petal length, petal width, sepal length, sepal width. Okay, and based on to this, because this particular flower data set has three species. So here he created a class or species, you can call it. And he started giving the names when he measured the petal length, petal width, sepal length, and sepal width. He started giving the name of the species. Means here there are basically three species, like here, Iris setosa, Iris, wait here, versicolor, and Iris virginica. Students, this setosa, versicolor, virginica. These are three species. Got the point? So that scientist took 150 flowers and he started measuring the petal length, petal width, sepal length, and sepal width, and start giving the name of the flower. Means here that based on to their petal length, petal width, sepal length, and sepal width, the flower is Iris setosa. Or based on these measurement, petal length, petal width, sepal length, and sepal width, the class species is Iris versicolor or virginica. So the point is here, let's understand in detail that what are these petal length, petal width, sepal length, and sepal width. So if you see this flower now, here, it is clearly mentioned that how the columns are created, how the attributes are created, or how the columns are created. You can see here, see this longer leaf here, this one is a petal. So he measured this petal and gave the name here for a petal length. So he created a column as the petal length. Then he measured a petal width. So he measured a petal width. Then he measured a sepal width and sepal length. And after that, he wrote that what this class belongs to, class. So suppose here, based on to the measurement value of petal length, petal width, sepal length, and sepal width, he gave a class name. Suppose this is one, as mentioned here, setosa. So he wrote that suppose if these are the measurement of petal length, petal width, sepal length, and sepal width, so these belongs to Iris setosa. Or any other flower he had measured, he said that this species also belongs to setosa. Again, he measured any third flower and he said, suppose this particular measurement of any flower belongs to versicolor species and the virginica species. So the point is here, he every time measured the petal length, petal width, sepal length, and sepal width, and start giving the name of that of that species, that this flower is basically belongs to this Setosa class, this flower belongs to versicular class or Virginia class. So he took around 150 flower measurement. 150 flower measurement he took it. Got the point here? So in this way, the data set is created. So students, these are integer, 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 and this one is string. So when we use the Seaborn, and whenever we want to make a category plot, means whenever we want to make a category plot, so inside the category plot, I can take one numerical variable and another string variable, category plot. One numerical variable and another string data here I can give it. So let's see. Suppose here, okay, so first of all, let me read this data. Wait, I'm writing here df iris is equal to pd dot read csv. Here I'm just calling one of the file iris.csv. Students, you can find it out in GitHub. In dataset 1, you can find it out. In a dataset also, you can find it out. Where in dataset 1 also, you can find it out. In repository, you can go, you can right now also find it out, dataset 1 or dataset. From there, you can find it out. Where is this iris CSV? Once I had loaded this iris CSV, I can see what is the iris CSV here. You can see here sepal length, sepal width, petal length, and petal width. And these are the sepal length, sepal width, petal length, and petal width. And correspondingly, they are starting from 0 to 149. It means 150 total rows are there. And these suppose these are the values of the sepal length, sepal width, petal length, and petal width. They belong to iris setosa, or some another are there. They will belong to iris versicolor and then virginica. So basically, these are the different categories are given here. Wait. Okay, so this one is there. So if I want to make a category plot, so one as a variable, integer variable, another one I will be taking as a string variable. So here, suppose here I want to make a strip plot here. So just wait. Here I'm just going to give SNS dot strip plot. And here, because I'm saying I want to make a category plot, so basically now one variable as an integer and another as a string value. So X and Y I will be using. 2 dimension I'm going to use it. In X, I can take any numerical data. Let's say, suppose I'm taking it as the petal length. Let's see, petal length. And here I'm going to give it as Y is equal to in Y is equal to, here I can give this particular class, same name. There should be no mistake of column names here. Now, what is the data source here? Data source is basically this one, df iris. Okay. So X is petal and Y is class here. So what I'll do, instead of this, I will be making a little bit change. You know, in this way it is giving, let me make it a little bit easy. Just wait, student. Here I'm giving it as Y. And this one, I'm shifting towards here. And here I'm making it as the X. That is much better. And here I'm going to write here. See this one. Here it is saying that iris setosa belongs to smaller petal length means its petal length is small flower. Iris versicolor belongs to medium length, and Iris virginica belongs to wider length. What does it mean? It means that Setosa, this is a Setosa, let's say. Setosa is a smaller flower, versicular. I'm not much better into the drawing. So versicular is a little bit higher side, mediocre flower. This one is a versicular. At versicular, so it means their petal length. This petal length is a little bit higher side, and this virginica has big petal length. Big petal length. So the point is here it is saying that virginica, from this I'm concluding, virginica has a higher petal length here. So it means virginica is a bigger flower. Versicular is a medium flower. Setosa is a smaller flower. If I want to change here, instead of petal length, I want to give any other. So what I can do, I can take, suppose here I can take a petal width also, I can give it this one. So what I do, for this line, I can change it. And here I can just give width. This one is the petal width here. So into the Y, I just change it to the petal width here. So this is there. Up to here clear? You can just raise hand. Up to here, the things are clear? Simple things here I'm telling you. You can just raise hand. Okay. Fine. Okay, now let's say some other queries I'm going to take it here. So this one is there. Now there's an underplot, swarm plot. So I can just make a swarm plot here. Instead of this C-bond here, I can just make a swarm plot. So I can see here like a little bit change will be there into the swarm plot here. Instead of strip plot, there is a swarm plot. No, it is a A. It is a A. In this way, it is going to be used. This one is a swarm plot. Little bit here, some congestedness is there, but here certain expansion of the points are there, data points are there. This one is a swarm plot. As students, what you can do now, when you are doing, you can change this Y on your own. Like here, I had given a petal width here or petal length, so you can change it to sepal length or sepal width also. Okay, you can do it on your own. Sepal length or sepal width, any of them you can change it. That is your choice here. You can do it on your own. Okay, so this one is a swarm plot here, SWARM. So like here I change it. Okay, alignment also I change it. Like here I change some alignment. X is equal to petal length. And in Y, I had changed the class. So in this way also you can do that. Means here you can try to change the alignment. You can try to change the variable name also, that you can do it completely. Okay. Now there is a value count. So suppose here you come. If I say that if I want to understand that inside this iris CSV, how many numbers are provided to how many rows are dedicated to iris setosa, how many rows are dedicated to iris versicolor, how many rows are dedicated to iris virginica, that I want to understand. Because total number of rows are 150. So I want to understand how many rows are dedicated to Setosa, versicolor, virginica, three different species. Okay, so that I want to understand. So basically here now, in pandas, basically, there is one of the function. In pandas, there is one of the function. Suppose ये iris na. In pandas, there is one of the function value counts, which will be counting out the values of class which is provided. So value count is a function inside the pandas, which is going to give you the total number of classes for each type of class here. So 50 for versicolor, 50 rows dedicated to versicolor, 50 rows dedicated to Setosa, 50 rows dedicated towards virginica, Iris virginica. This one is the pandas operation here. There's one of the function here. The count. Oh, it is underscore somewhere, no? Some lines. Okay, see, measure these two now. Please see carefully. Here it is saying 50 rows are dedicated to versicolor, 50 rows are dedicated to Setosa, 50 rows are dedicated to virginica. Here also it says Iris Setosa number of rows are 50, Iris versicolor number of rows are 50, Iris virginica number of rows are 50 here. Okay, so this one is a cbond.sns count plot function is there. Okay. No, there is no any mean of petal and sepal. Directly you have to take the variable name here. Sepal is the variable name here. This sepal is a variable name. I had already told you this sepal is a variable name. I described everything. Sepal length, sepal width. Sepal is basically a flower, this part. Flowers like wide petal, wide area. Let me show you, just wait here. This one is a sepal basically. I had explained also. Be careful. This part is basically a sepal. This one is a leaf. This one is a. Have you studied well your science in during your school days? Intermediate school days here. So there is a sepal and petal concepts are there. So these are the sepal here. So this one is a flower sepal basically, and this one is a petal actually. So this one is a sepal length, and this one is a sepal width. This one is a petal length, and this one is a petal width. These are just in 7th, 8th grade, 9th grade, these terms are there. So these are sepals basically. So from these, the measurements has been taken, and they has been taken into the form of sepal width, petal length, petal width, sepal length. So these measurements have been done there. Okay. So this is there. Now, students, whenever I want to get any data set name, so what should I give there? So simply I will be writing here SNS dot get data set name. So here I am having a lot of data set, which I can use it for my C1 plot, that I can do that. So here there are a lot of data sets, such as I can say diamonds, exercise, flights, Iris data set also it is there. miles per gallon, penguins, planet, taxis, tips, Titanic, a lot of data sets are there. If I want these data set for SNS work, Seaborn work, so I can take it from here. So Iris also here I'm having. Okay, so let me just do certain work here. So, okay, if I want to load a Titanic data set here, okay, so what command I have to give? SNS.load dataset Titanic, I have to give it here. So here I'm just giving Titanic DS. Titanic DS is equal to Seaborn dot load dataset. And here now I have to give the name of this Titanic. Same name I have to give it here. Titanic, this one, Titanic, and it is there. So this Titanic data set is basically actual data set, which this Titanic ship wrecking was happened in 1912. So this one is the actual data set where all the details are there. Nearby 891 rows are there, which was collected from the earlier databases. And here all the details for that Titanic related people were there almost, that what are the people who boarded that particular ship, whether they were survived or not. So this type of data, they had collected it here, certain what are the genders there, what is the age, whether they are having a sibling, what fare at those time, never, it's 100 years now. So what fare they had concluded, okay. In which class they were sitting, in first class, second class, or third class. Certain deck is also given. Certain, okay, embark town means from where they are picking up and up to where they have to move, destination point. Alive also, whether they were alive or not. So this type of data has been collected earlier. And there were 891 rows are there with 15 columns. Details up here. Okay. How many of you have seen the Titanic? You can just raise hand. Let me know. How many times, like many of you have seen Titanic, almost everybody. Yes. And recently one case has been happened now. I feel two months back. Just one crew is want to search that Titanic ship wreckage also. They are going to the deep sea and in certain capsule, and they something happens there. Okay, with the capsule, everybody knows that what is the case there. Okay, so this one is the actual data set. Yeah. Everybody knows about that. Never 2 to 3 months back that happened actually. Just to find out the ship wreckage. Okay. Yeah, they lost their life. Of course. Yeah. That happened now because some flaws is there and a lot of things are there. Okay. Okay, so this one is the actual Titanic data set. So the information is also provided here, whether they were survived or not, so whether they're alive or not. So that one is there. Okay, so let's explore this data set here. So what I'll do here, I'm going to load this data set. See here, if you want to see that what are the columns, so here simply you can give the variable name, Titanic DS column, all the variable names are there. Now here you can see Titanic DS class. There's a class also. You can see here, there's a class here. This one is a class here in Titanic dataset. This one. Okay. Now, the first class, second class, or third class. Of course, see in any ship, anybody has traveled ship? Cruise. Okay. See here, basically. In a ship, some decks were there. Oh, many of you. Good. You should be aware that suppose this one's the first class, this one's the second class, this one is the third. Almost everybody has traveled. Okay, good. First class, second class, and third class. So the people sitting here, they had, of course, they had taken a higher rate ticket. So all the facilities related with a life-saving jacket, and other tools or accessories which are requiring for the life-saving, that one is boats. I can say both. Life-saving jackets and the boats, they all are provided to the first class because their ticket rates are higher. The same is happening to the second class also. Life and ticket, life-saving boats as well as jacket, everything has been provided almost. Got the point here? Okay. And let's come to the third class. So what happens? Number of people are slaves here. Even they have not purchased the ticket well. So they are slaves here. They are just traveling from one place to another. Okay. So the point is that they do not have any access to any life-saving jacket or the boots. So if you see the data set now, you will be getting a lot of lives has been lost with the third class deck. Means the people who are sitting into the third class deck, so they had lost their life because no shape, no life-saving boot, no life-saving jackets, nothing. Means no accessories are there with them. So that happened. So here now, if you want to see the data here in from this graph here. So if I want to check it out, what is the survival rate? I can see what is the survival rate here. So if I'm coming here, Titanic DS class, if I'm giving it here. So third, first and second means second, first, third class are there. These are there. First, second, third class are there. Now, students, I want to understand that what are different, how out of 891, how many total number of rows are dedicated to first class, second class, or third class here. So this is 491 rows are dedicated to third class. Maximum number of people are sitting into the third class. In first class, 216 people were the writers, and into the second class, 184 people were the writers here. So the point is here that out of 891, these are the different categories here that they are actually different rows, that these number of rows are dedicated to first class, second class, or the third class here. Okay. This one is Titanic DS. If I want to plot this data, which I had plotting it with the pandas here. So here it is just showing you the same rate with a seaborne count plot. So this one is also one of the category plot here. Here it is showing that into the first class, nearby 216 people were there. Into the second class, nearby 184 people were there. Into the third class here, nearby 491 people were there. Okay, so this was the category plot, which is going to show you that how many countings are there for the particular rows in complete data set. It is there. Okay, up to here, all the things are clear to you. You can just raise hand. It is easy now. It is interesting now, right now. Okay. Fine. Now let's see. Let's make the category plots basically. Let's make the those who are not clear enough. So what you can do, you can please rewatch the video. And if rewatch the video, because I'm explaining everything 2-3 times every concept. If you rewatch the video, so you will be getting much more clarity. Here just we are plotting all the data here. Okay. Now let's see, suppose here, there is one of the category plot. Basically what this category plot will do. Inside the category plot, if I want to understand that nearby, I want to understand the data that nearby, how many approximately people survived. And I want to understand the data with the help of gender also. because there are a number of people survived and not survived. So I want to understand the survival ratio, and I want to understand the survival ratio with the help of what? Uh, Gender, basically. So what I'll do, I'm going to take this category plot. So first of all, let me take this category plot here. And let me tell you, inside this category plot, how can I make the 3 dimensions also? Because currently, if I'm taking this data, see up to here, I'm taking this data. Like here, I'm taking this data X and Y. So basically, these are 2-dimensional data. Means 2 variable here I'm taking. So here, what I'm going to do, let me take this data. Let me explain you what is going here. Just wait. Suppose here I'm writing cat plot. Here, I want to understand that what is the survival ratio. So in X is equal to, I want to understand class, that in which class, suppose your first class, second class, or third class, in which class there is one of the parameter inside the cat plot, X, Y. I want to understand the survival ratio as per the different classes, first class, second class, and third class. Where is the data set? Inside tightening data set, the data set is present here. So what I'll do, let me give this query, this line particular, this small line I had given. So let me make it. So here it is not very clear. So what I'll do here, let me write here, kind is equal to bar, which will be helping me that just to understand the data in detail. So there is one of the parameter kind. Kind is equal to bar, which will be giving me the bars basically. Now you can see for this line number 30, bars are created. So basically what it is saying you, just wait. Just wait. Just wait here. Just give me time. Just wait, please. Wait. There's no change. Just wait. Okay. Here, okay. See here, what it is showing to you. Here it is showing to you that in first class, see this first class is raising upside here. You know, this line also, this line is moving towards upside. It means they are moving towards one side. What does that mean? From 0 to 1. If the lines are towards 0, 0 or up to here, so it means the survival ratio is very poor. And if this line is stretching, this particular bar is stretching towards upside. So that is reaching towards one side here. Right now, here it is given 0.7. So it will go 0.8, 0.9, 0.1. So basically, it is just showing that maximum survival rate is going in first class. And then second, after first class, in second class, the survival rate is high. But in third class, there is no survival rate. You can see here, it is just coming to 0 to 0.3 or 0.2 only. So here it is just giving the survival rates are not very much into the third class. They are almost 0. But the survival rates are extreme higher in first class and then in second class. Now I want to understand this data as per the gender also. So it means I have to take a gender variable. So that one is the third dimension. I'm going to take it here. So you can see there is a gender variable as a sex here. So I can write here, there is a third parameter. If I want to give a third parameter, that parameter I should write here hue. Hue is where I can give the third wait here, where I can give the third parameter here. This was the third parameter here. I'm going to give it. And here I'm just running. Just wait. See here, you've got this line. You can see this line now. So here you can see seaborn.cat plot. Just to try to make us understand which class has maximum survival as per the gender from the Titanic data set in the form of bar. So here it is showing you. You can see this legend also. Blue color is provided to male and this orange color is provided to female so that we can have a category. Here it is saying first class. Maximum survival rate is 1. 1 means live. Means the person is living. The person has a success. Means the person is capable to reach the shore and they are alive. You can see it here. 0 means not alive or in between somewhere here. So almost not alive. So the point is here now, how we can understand? In first, what happened in first class? In first class, maximum survival rate is there for the females. Maximum survival rate is for the females in first class. But for the men, for the male, the survival rate is not in first class. If we check it out a second class, the maximum survival rate is for the female, there is 0 survival rate for male. This one information is coming from the data actually. I'm not giving. But here that one is from the data it is coming. But here, if you check it out, the third class, there is no survival rate for the men and women. Now, how it is coming? That some survival rate is there coming for the female category in first class as well as second class, means maximum survival rate in that shape, which is coming from the database. Don't think that I'm going to give this one. I'm just giving you as per the terms which our bar is showing to me. Okay, so here it is just saying, see, this orange bar is moving towards 1. 1 means alive. And if it is somewhere here or down, so it means not alive. So the point is here, even you can just check it out, this data from here also. Survived, gender, and class. These 3 also, you can just check it out. 0 or 1. 1 means survived, 0 means not survived. So here, so the point is here now, basically what happens that what happened in first class? When the ship starts sinking, even what you can do whenever you have time, now you can rewatch the movie if you are willing or you are having the time, just for the recall. What happened when the ship starts sinking now? Because the people who paid, who are into the first class, they have paid more for the tickets. So life jackets and boats are accessible to these people. Now what happened? Most of the male, they gave their life jacket or they asked their females or even I can say kids or old people just to go away into the boats. And they also gave all the life-saving accessories to their males or kids or old people and let them go. The same happened into the second class also. So that's why the survival rate of females are high in first class and the survival rate of female are high in second class because their male community just let them go, means they just asked them to go. Okay. And so the survival rate is very less here and here for the males. But what happened in the case of third class here? In third class, because slaves community was there and they had not paid. Okay. So fare is very low, you can say, or not paid or very low, whatever is there. So the accessory life-saving boat or life-saving jackets are not provided. So of course, they do not have any kind of life-saving accessories, you can say it. So they are driven basically, they are drove, they are not escaped in any case here. If you want to make it this movie a little bit rewatch from those things, you can just check it out. That people are just sending their ladies and children's and old people into the lifeboat. So you can see these things. So from there, you'll be getting an idea. Okay. So this basically graph category plot is conveying us this information. So basically, in C1, we can give the 3 dimensions as well. So 1 dimension, 2 dimension, and 3 dimension also I can take. So 3 variable data also I can take it here into the C1 library here. Okay, so this is there. Fine. Now there is one point here. Suppose here, right now what I did, see here, students, I had taken a kind is equal to bar now. So that's why I'm getting a bar. But at the same time, if I want to give here kind is equal to violin, so I'm not getting much information. So this is not a right graph. So I will be taking kind is equal to bar. That is much better. So if I want to see more details for this one, so SNS.cat plot, because there are many values of the signature here, so just like here it is giving that whenever we are using a cat plot here, I need to give first variable in X, second variable in Y, and third variable in hue, and in data as the data source, I need to give it here. And in kind here, kind, so which I'm giving as a bar, so that's the perfect method. But if I'm giving here violin, so that is not working well. So here, see here it is just showing now. In kind, we can give many of these values. These values I can give it box, violin, bar, this one. But here now we have to specify that which value we need to give it here. So whichever is suitable in kind option, I can give a strip, swamp, box, violin, point, bar, count, that I'm giving it here. So here I tried the violin also, but that is not working perfectly. I am just giving kind is equal to violin. That is not working perfectly. So I removed it and I just gave a bar because bar is giving me some information here. So that is not working. Okay. Now, if I need one of the data set here, such as tips data set. Okay, let me tell you, again, I'm going to write it here. SNS.get data set name. So basically here we are using C1 library just to explore the data set. I want to see the insights of the data set, what this data set is speaking to us. So there is one of the data set, tips data set. Okay, this one is related with certain restaurant information. So here I can just take it here. So here I can just write here DS tips is equal to SNS dot load data set, and here I can give you a wait here tips. Okay, so I'll just load this tips data set. So let me write it here. DS tips, I can give it here. So what this tips is giving to me here, tips data set carries the restaurant information. Here it is just giving me the details of the total bill. How much tip the people has gave, gender, whether the people who are coming, they are smoker or not, on which day they are coming, all the Saturday, Sunday, weekdays, details are given. Time, into the time here, dinner, lunch or breakfast, when at what time they came. Size also, into the size here, whether 2 people came, 3 people came, or 4 or 5, that is there. So almost a long data list is there. 244 rows into the 7 columns are there. Now let's explore this data set. Okay. So here, now what I can do, let's understand, suppose total bill I want to understand. What is the average total people are paying? So I can make a volume plot here. So DS tips is the data source, total bill is the column name. So volume plot directly I can apply it here. SNS dot void SNS dot volume plot X is equal to, and here I can just pass on this total bill. Students, there should be no mistake into the total, into the name of the column here, otherwise it will not work. Now, after that, I need to give here, what is the data source? So inside the data, I have to pass on this DS tips here. I need to give here that this one is the DS tips here. Okay. So this one. From this one, I am getting one idea that around how much bills the people are paying. So that one is almost, you can see the fattiness. Here it is giving the information. The bills are being paid nearby $10 to $20 maximum. Majority of the people are paying the bills between $10 to $20. Very few people are paying the bill between $40 to $50. $40, $50, least people. But majority people are eating all the things between $10 to $20. This is one of the information. The same if I want to drag out the information, approximately what tip people are paying. So in X, I can just write here, tip. I can just write here, tip. Students, you have to write everything on your own so that more and more you could be practiced. Here it is giving me idea that maximum tips are being paid nearby $2, means I can say $1, $2, $3 maximum. Very few people are paying a tip of $6, $8, or $10. Of course, that's too high. Okay, so this information, I dragged it out from volume plot here. Up to here, it is clear? You can just raise hand. It is quite easy. Is it interesting now? C1 is very interesting, actually. You're enjoying the library now, students? Okay, thank you. Thank you. Fine. So now let's go ahead with certain distribution plot. Like above, I had told you about certain category plot where I had just provided you swarm plot, strip plot, count plot, cat plot. They are basically the category plot. But here, if I want to understand certain distributions of the plot, so there are other plots such as dist plot, hist plot, joint plot, volume plot, rug plot. So these are certain volume plot here. Okay, so you're enjoying the session. You're enjoying it here. Thank you. So here, this distribution plot, hist plot, just to plot the histogram, joint plot, volume plot, rug plot. These are certain plots which shows you the distribution of the data. Okay. So volume plot already I had shown you here that how I am taking the volume plot here. Okay, just wait here. Oh, you can see this distribution plot here, hist plot. Hist plot shows you what is the histogram. Means how many, what is the count of the data, you can say. It shows you the frequency of the data. It is, you know what is happening? It is DS tips here. DS tips here. So basically histogram shows you the count of the data. Count of the data. So means here, how we can understand, it is just showing you that majority of the bill are being paid between $10 to $20. And suppose here, see whatever, suppose I say $18 it is. So nearby about 35 people plus, 35 plus people paid nearby $18, or I can say, suppose I say $12, nearby approximately 28 people paid a $12, or suppose here I can say like here, nearby $14 or $15, nearby 31 people paid $14 or $15, or suppose here nearby 5 people paid only, suppose I say $4 or $3 bill for certain small things. So the point is here, histograms gives you the distribution of the number of counts here. Okay. So here, whenever we are writing a histogram, we need to provide the data source and to which particular column we want to make the hist plot here. Bins is 20 means here, basically general bins here we are giving 20, but default here it is taking 10, 10, 10. Reason being because here the data are provided into the 10, 10, 10, like $10, $20, $30 in this way. Okay. So this one is a distribution plot here. Now here, if I want to give tip, you know, there is one of the variable tip. So if I want to make a tip here, that show me the distribution plot of the tip, because you know inside, oh, this one is the DS. This one is the DS. So here it is showing you the tip of rate of nearby people who are paying tips, they are paying tips nearby $2 to $4 maximum. So you can say maximum distribution. This one is a distribution plot. Maximum distribution is coming for this data is between $2 to $4. You can see the peak here. And inside the distribution plot also you can see these bins are intervals. These are the default intervals. So here you can see this line. So this line shows you where the peak line is there. Peaking, this peaking. Okay. Where the peak lines are there. So here it is just showing you that peaks are giving you the distribution. The majority of the peaks are $2 to $4. Yes, if you want to make the distribution plot of total bill, you can just write here the variable name total bill. Here it is just showing you the total bill distribution plot here. So you need to see the peak here. Where the peak is going? Peak is going here now. So where the peak is going, that one is the highest distribution. So distribution here it is making that majority of the bill are being paid between $10 to $20, and these are the minimum bill and these are the maximum bill people are paying. But very few people are paying $30, $40 or $50 higher, but majority are going between $10 to $20. Okay, so this one is there. Okay. Right now, the default bins or interval are going with a 10. So here, if you are increasing the number of bins, suppose here I'm increasing the number of bins to 200. So see how these peak lines are coming here. So that's why we just generally give the interval as a 10 or 20 here, right? So this shows you the distribution. There's one more thing here. Whenever we are giving the distribution, so bars plus this line I'm talking about, this both will come automatically. Now, why this line is coming? Let me tell you, because what happened, there is one of the parameter inside distribution plot here, KDE. So that parameter is by default true. Kernel density estimation, which shows the density of the data. So basically now, if I show you SNS dot dist plot question mark here, if I want to show you. So you can see here, there is one of the parameter KDE. This KDE is equal to true is showing you this line. And suppose I do not want to show this line, so I need to make it as a false. So if I am making it as a false here, so you will never see this line. Got the point here? So we need to settle down this signature basically. So here, if I'm coming here, suppose this, wait. What I do, I'm going to take this line, just wait here, this line, and let me make it in a normal. Suppose this one is working. It is just taking the DS steps here. Let me write it here. It is making it here. So the default one is, suppose I'm making the distribution plot of total bill. Bins, you can give it 10, 20, whatever is there. Right now, you can see this this line here. Can you see this line? Now what I'll do, I'm writing a KDE is equal to by default student, this one is a true. That's why you are able to see this line. But here I'm making KDE kernel density estimation as false. You can see there is no line there. This type of line, curving line is not there because kernel density estimation is equal to false here. But if I do it again, the default, if I'm writing it here, true. So you will be getting the line again, this line again. Okay, so this I'm showing you how to settle down the parameter, how the changes will be reflected. Okay, so here I just given KD is equal to false, so no line is there. If you need, by default, it is true. Now there is one of the I will say plot is there, KDE plot. kernel density estimation plot here. This one is this one. You can see here C1.kde plot where tips, inside the tips, I can just give a total bill. So students, what you need to give here, you need to give the data set name. If you are having a DS tips now, so you have to give a DS tips, then total bill. So you need to take care what is your data set name. So here it is just giving you only line because this one is related with the KDE plot, kernel density estimation plot here it is going to give you. These lines shows you the density estimation, where the densities are going higher, what is the distribution. So here it is just showing you the distributions are going high between $10 to $20. And like higher side, if you are taking about the 40, 50 or 30, so the density is low here. Okay, now this one is a joint plot. Inside the joint plot, we can have a composite view on multiple variables. Suppose here, this one is a joint plot. You can see that you are having the bar plot, and even you are having this one as a scatter plot. So I'll tell you what is this. Suppose here I want to make a joint plot of total bill and tip. Total bill and tip. So basically, in X, total bill is there. So this total bill, in X, total bill is there now. So here it is just showing you the total bill is between $10 to $20 as the highest one, this one. And if we are talking about the, in Y, I am having a tip. In Y, I am having a tip. So you can see here, see this higher bar, this higher bar. So here it is showing you the maximum tip is given between $2 to $4. Okay. Okay. You can see here also. This line shows you that when this scatter plot shows you when there's an increase in total bill. See this one. When there is an increase in total bill, there's an increase in tip also. When there's an increase in total bill, this increase, so the increase in tip also is there. This scatter plot shows you. So, and you can see the density between here $10 to $20 and $2 to $4 tip, $2 to $4 tip. So here, maximum the data are lying here. So it shows that when like maximum bill are going between $10 to $20 and tips are going between $2 to $4. And when this bill is increasing, total bill is increasing, correspondingly your tip is also increasing. Suppose somebody has taken a food nearby $40 to $50. So correspondingly their tip is moving towards $7 or $8 also. If somebody has purchased any, suppose I say any food for $30, so nearby tip is also they are providing nearby $6 or nearby $5 also. So the point is there, when with increase in total bill gives increase in tip also. We are using all this graph just to understand the hidden insights of the data. We are trying to understand the pattern of the data sets. Means the numerical value which we are having inside the data sets, that I can understand with the help of graphs. So all the numerical values are present inside the DS tips, but here I am understanding, yes, there is a total bill and tip, but here I am understanding with increase in total bill, the tips are also increasing. SNS.rug plot. Data is equal to tips. So here, X is equal to tip. So here, this was the rug plot where I'm just giving the data set name and the tip. Students, you have to take care. If I'm writing here DS tips, so you are also going to write DS tips. Means here, whatever data set name you are providing while loading, so you have to take care for that one here. Okay. Okay, so you can see here that rug plot is one of the method here where you can just see. This is also one of the plot where you can see the your any of the variable you can take it and you have to give the data set name also. But this method is showing you, like here it is showing you that what is the tip here. So you can see the dark shade here. You can see here this dark shade here. So here it is showing you the maximum tips are going between $2 to $4 here. If I want to see this rug plot with two variables here. So here it is showing you the rug plot here that the total bills are going, because here I'm just giving in X, show me the total bills, and Y, show me the tips. So here it is going to give me this variables here. So here it is just showing you $10 to $20 total bill and $4 to $2, $2 to $4 tips are moving here. Okay, so with increase in the total bill is also increasing the tips as well. This one is there. Okay, now you can see here, suppose I'm taking this one. So there is one of the plot here. See, there's one of the plot here, box plot here. So here, what I do, just wait. Suppose here, I want to understand. So let me, I'll just change it a little bit here. Suppose this one is there. Seaborn.box plot. Suppose I want to understand that on which day, how much total bill people had paid. On which day, how much total bill people had paid. That I want to understand. So you can see this line number 49. Line number 49. Here we are able to understand that on which day Seaborn.box plot, on which day what total bill people has expend, means how much bill the people has given on which particular day. So from this graph, I can understand that from the above data set, on Thursday here, on Thursday, people had paid minimum bill, because I told you this box plot gives you minimum information and maximum information. So from here we can understand on Thursday, nearby minimum bill has been spent approximately $8 and maximum bill has been spent up to $30. But if we say from this data, on Thursday and Friday, almost similar bills are being paid, but highest number of bills are being paid in Saturdays and Sundays. So it means in weekend, people are paying much more bills. They are expending more. So from this data set, I'm going to conclude this. And they are showing me some information such like on Saturday, minimum bill, maybe they had paid about $4 and maximum bill they had paid about $40. On Sunday, minimum bill approximately $8 and on minimum bill around $8, maximum bill nearby $41 or $42. But overall, the maximum measurement, the maximum bill payment has been done on weekend by the people. So it means here people are paying much more bill on the weekends because they have time, they can spend time with their families and they can come, families and friends, and they can come into the restaurant, they can spend it here. Okay. So that is there. Okay. So suppose this is one case I had taken. Now I want to implement the same I want to implement here. Dear steps. So here I'm going to add one more. Q is equal to smoker. You know, there is one of the variable actually. There is one of the variable. Smoker is one of the variable. I want to understand the third variable also. Smoker, yes or no? So I want to take the third variable. So third variable I can take into the hue. And in that way, I want to understand that from this data set, among which people are just spending most here. Okay, so that I want to understand here. So just now I need to interpret here. Okay, so what should I understand from this data? See carefully, students here. See here, smoker. Yes, the people who are having the smoking habit, they are in blue, otherwise in orange or yellow. From this data set, you can see here, see this one, Saturday. On Saturday, maximum expenses or maximum, maximum expenses has been done by the people who are smoking, who are into the smoking activities. So they spend a lot, I can say. The same is happening on the Sunday. So the point is here that on weekends, maximum expenditures are coming from the people who are having the smoking habits. Okay. So on weekends, they are spending more because time is there, or one can sit it with the families and friends, they can spend their time just into the restaurant, that is there. But here now, in general weekdays, there is not much expenditure, but the expenditures are coming on weekends by the people more, means they are expending more as compared to the expenditure not done very well with the non-smoking people here. So this is like idea generation I'm getting. The people who are into the smoking activities, they are spending more. Okay, expenditure I want to calculate here. So this is there. Now there is one of the, okay, right now students here, I'm just making all these data one by one, I'm making it here. Now suppose here I want to make it as a as a complete data, means I want to make a complete data set. I want to make a complete pair plot. I want to make a number of plot at a once. Instead of one by one, I'm making it here. So there is one of the function here, c1.pair plot, where I am getting c1.pair plot, where I am getting this type of pair plot, you can see. Okay. So this is there. So here, what will happen in pair plot? It will take all the columns from a data set. It will take all the columns from the data set and start making the pairs individually and start making the plots here. So here it is just writing. See here. Tips, total bill. So this one is a total bill and tips. So with increase in total bill is increasing the tip also. Okay. Here it is just showing you tips only. What tips has been paid by the people, right? Here also it is just making total bill and tips. This data it is just making for the total bill. How much total bill has been paid? Tips and total bill. And here total bill and size is given. So the point is here basically different types of plot you will be getting in pair plot. So all the variables, the data set will be taking all the variables and this SNS will take all those variables and start making the plot of them here. HUE is coming in smaller letter and it can be written anywhere, does not matter, but hue is going to take the third variable. It is not in middle, it is going to take, means here first variable, second variable, third variable, then data source here. I'm giving it. Now suppose here, wait here, this one already I did it here. I did it here. Total bill, already I did it here. Day, yeah, I did it here already. This one already I did it, category plot, total bill, whether the people are smoking or not, this one I did it here. Now here, let me take out the iris data set. This one is the iris data set, I'm just taking it here. Already we did it here, swarm plot. I just created it here. Just, okay, these are the again repeating here. Okay, let me take out that one of the data set here. Inside the get data set name, there is a one of the data set miles per gallon. I'm just loading this data set, c1.load data set miles per gallon here. So you can see students, inside this miles per gallon, you are getting miles per gallon, variable, number of cylinder, displacement, horsepower, weight of the car. Means these are certain vehicle related informations are there, acceleration, on which date, which particular model year that particular vehicle is built, manufacturing date, where, what is the origin and what are the names of the cars are there. So if I want to use this data set just for the plotting purpose, I want to understand what are the inside of the pattern of the data are there. So I can use them. So here what I can do, because there are a lot of numerical variable, MPG, displacement, horsepower, weight, okay, acceleration. So these are the numerical variable. I can use all this number data, numerical variable in numerical plot. So I can make various plots such as scatter plot, relational plot, line plot while using the numerical data. So here, if I want to make a scatter plot, so inside the scatter plot, I can take any two variables which are integer. So here I'm writing c1.scatter plot data is equal to mpg ds. This one is the data set name here. X is equal to mpg, y is equal to weight. X is equal to mpg and y is equal to weight. Here I'm taking miles per gallon and the weight. Miles per gallon and the weight. So here it is just showing that if any car weight is going heavy, So automatically miles per gallon are reduced. This one is the negative. See, if my scatter plot is moving this side now, this side. So that shows the positive impact. If this variable is increasing, corresponding this variable is increasing here. Okay. And if this graph is reverse here, so it means that one shows the negative impact. It means if weight of the car is increasing, so miles per gallons are automatically decreasing. Size versus, see, this one is the size versus total bill or size versus tip. No. So if such type of graph is there, that show no relation is there. Because number of people are coming, suppose 4 people are coming or 5 people are coming, that does not impact on any kind of relationship of total bill or tip. Okay, so if such type of graph is coming, so that shows there is no relation. Like here it is showing some relations are there. Okay, that is, here it is normally showing that 2 people are coming, 3 people are coming, 4 people are coming, but here it is showing no relations are there. So this one is a scatter plot. Suppose here I want to make a scatter plot of horsepower and MPG. So it is just declining. Okay, so you can take any 2 variables here. Suppose here I want to make a line plot. I want to make a line plot of weight and MPG. So you can take any 2 variable which are integer and with the data source name. So you can start making the line plot, scatter plot. So here it is also showing if the weight of the car is increasing, correspondingly your miles per gallon are decreasing here. That shows the negativity. Relational plot is there. You can see REL plot. So you can take any numerical variable, 2 numerical variable and start writing its plot. Relational plot, scatter plot, none of that you can write it here. There's a regression plot also. Whenever you are using a regression plot, you'll be finding out a line in between. You can see this line. This one is a regression plot where 2 variables I'm going to take and the data set I'm going to take it here. There's a box plot which will be taking a one variable only. C1 dot box plot x is equal to weight. So here it is just showing you that maximum weight of any vehicle or a car is 5. No, this one's above 5,000. 5,000 plus, and the minimum weight is 1,500. Displacement is one of the variables, so it is just showing you maximum weight is 450 and minimum weight is 50. There's a rug plot. In there also I need two integer variable. So weight and MPG is there. There's a joint plot also inside the joint plot here. Joint plot here, data is equal to MPG data set. X and Y is there where weight and MPG is there. So you can see here. SNS dot joint plot. So in joint plots, you can take any 2 variables and start making the plot here. So here multiple graphs will be there. You can take any. By default, it is going to take the scatter plot and this bar plot here. And if here you want to change this kind, so you can make a KDE. So inside kind, whatever values are present, you can just write it. Not only this one, any other values are there. So if you want to see like what more values you can give it here inside the kind, so simply you can write here. Like if you want to see more here, SNS dot joint plot and signature you want to see, you can see it here. There's a kind. So inside the kind, you can read what more value we can give it. Inside the kind, you can give scatter, KDE, hist, hex, ridge. Any of these values could be provided inside kind here. Okay, so this is one is there. So you can settle down kind KD. So you can say how the values are coming with the kernel density estimation. If I'm writing here kind is equal to hex, so you can see how hexadecimals are created. Hex value, hex, KDE, I'm just trying. So you can see how the things are changing here. With the hex value, how this hex values are coming. Strip plot is there. Suppose here, there is inside this MPG data set here, there is one of the variable here, origin, US, Europe, and Japan also. If I want to understand the origin of this penny car and their correspondingly miles per gallon, means here miles per gallon and origin. Miles per gallon and origin to these two columns I want to understand. So what I can do, I can just make a strip plot. Like here, I'm just giving here data set name, X is equal to origin, where these cars are manufactured, US, Japan, or Europe, and Y is equal to miles per gallon here. So students, can you tell me from this graph, what you understand? As per the data set, which particular origin country is manufacturing a car with highest miles per gallon? Tell me which particular manufacturing country produce highest miles per gallon cars there from this data set. What do you understand by this data set? You have to give me the name. Very good, Sandra. Very good. And I need certain more answers also. Yes, very good. Those who are providing me answer, very good. I can understand that you are able to understand my whole class now. That what this, basically what this entire class I had made you understand, that how we can understand the pattern of the data. Thank you for a response. So your answer is Japan. Japan is the country origin where the cars which are manufactured, they are having the highest miles per gallon. Students, those who have not answered me yet, you have to answer which particular country, as per the data set, is showing here with the least miles per gallon. Least miles per gallon. Least miles per gallon. Yes, yes, please come up with your answer. Many students are coming with the answer. Please come as per the data, because that gave me the clarity that really you are really understanding the class here. Yeah, of course. Thank you for your responses. Very good. Keep it up. So US, as per the data set here, it is saying USA is the, if any car origin country is the US, so here miles per gallon is low, and in Japan the miles per gallon are very high as compared to overall. Thank you. Yeah, thank you, thank you, thank you. Swarm plot, you can see it here. The data points are spreaded here. Okay. So you can make, like here I'm making a strip plot, a swarm plot, the spreading of the data are there. The data points are much more spreaded. But here also it shows Japan manufacturing, all the cars which are manufacturing in Japan, they are giving the highest side, highest miles per gallon, the rest are low. If you want to see this data as per the category plot here, you can make data source name, X is equal to region, Y is equal to MPG, and kind is equal to box here. So here into the box, here also from you can understand Japan is the highest miles per gallon giving country here. If you want to see more, there is one of the column here. Students, here is one of the data set here, taxis. You can see it here, taxes is there. Inside this taxes here, there's a lot of data sets, a lot of column names are there, such as passenger, distance, fare, tip. So I can take this here data here, such as distance, travel, fare, tip, total fare, color of the car, payment mode, credit card or cash. Okay, I can take any of this data. So if I want to use two integer variable, I can make any numerical plot. And if I want to make a category plot, so there one variable as an integer, another one as a string I can take. So here I'm just taking scatter plot. What is the data? What happened when distance is increasing? What happened to fare? So when distance is increasing, correspondingly fares are also increased. Maximum number of people are traveling within the distance of 20 to 25 to 25 miles maximum distance they are traveling. Few of the people had traveled the distance of 30 or 35 miles also. So correspondingly, their fares are very they are varied, they are up. Maximum people are paying the fare of between $1 or $2 to, you can say, $50-$60. Okay, that much. But with increase in distance, fares are also increased. If I say inside the taxes, there are two colors here, like here, yellow color and green color. Yellow and green is there. So if I want to understand that there are nearby, how many rows are there? 6,433 rows and 14 columns are there. I want to understand how many rows are dedicated towards the green car or yellow car. So here, if I'm using the value count functions of pandas, 5,451 cars are yellow car, 982 are green. The same I want to make a count plot. You can see the same data present here. Maximum cars are yellow. Now there are two modes of payment here. Inside the payment, credit card or cash is there. Cash or credit card. You want to understand what is the payment mode here. So with the value count function, you can take it out with 4,577 rows dedicated to credit card, 1812 number of rows are dedicated to cash payments. The same, you can just make it the count plot here. If you want to make a strip plot, so here I can take one variable as an integer, another one as the string. So here you can see, like if I want to make a strip plot for color and the fare, okay, yellow car, people sitting in yellow car, they had paid up to the fare of $60 nearby. And the people who are sitting, who had taken the green car, they had paid they had paid nearby $40 month, $40 bill. But number of people are paying these range of the bills also. But here, maximum bills are normally going to $50 to $60. Okay. Box plot here. Box plot, if I want to make it for color and fare, and I want to make the third variable payment also. It means show me the car of the color, their fare, and what payment the people are using, credit or cash. So credit card is just shown by blue color, cash is shown by this red color. So here it is showing you that in yellow, the people who are hiring yellow car, they are paying both modes. I can say green color, they are paying credit card and cash, both. But the people who are taking green taxis, they are paying much with the help of credit card. Maximum people prefer credit card. There is one of the plot here, LM plot. If I want to take the distance and the fare, you can see how this LM plot is giving you the output here. In LM plot, I can give one more third variable also, distance, fare, data source, and payment mode I want to understand. Whether it is a credit card, people are paying through the cash or credit card. So here I'm getting one idea. See, this red color, cash. So, or blue color credit. So from this, I can understand people who are traveling to the various distance. So correspondingly, fares are also increasing. But credit card, but maximum people prefer credit card. Blue color is coming now. Maximum people prefer credit card payment. In LM plot, I can give the fourth variable also. Like here, distance where two variable in here payment I'm just giving, and I want to understand it with color. Fourth variable. So here it is just showing you this graph as per yellow car. This graph they had created as per the green car. Okay, that in yellow car, if you see the payment mode, in yellow car, uh, payments are being done with the help of a credit card as well as cash also. But if you see green, the people who have traveled green car, so green taxis, you can say, people are much preferring the credit card. Very few people had given the cash as a payment. You can see very red are very less, so that is there. There is one very popular data set here, SNS.load dataset flights. Flights is one of the data set here. Here we are having year, month, and the passengers. In which particular year, in which particular month, maximum numbers of passenger traveled. This information is there inside the flight data set. Now, students, here, if I want to understand this in detail, so see here, I just loaded this data set, flight data set. I'm just coming here. And here, I will be loading this data set in a different mode. I will be using a pivot table, which will be making me the data set to understand actually. So basically, when I'm loading this data set, SNS.load dataset flights, here I'm just giving. So here I'm writing flights.pivot table. So basically, Pandas has one of the pivot table where I can pass some parameter, such as here I'm passing parameters such as month, year, and the passenger. So here in month, it is going to take out the month. Year, I can take out the year. And here I can just give you the passenger names. Sorry, passenger, number of passenger. This one is the number of passenger. So what should I understand with this pivot table? Pivot table gives me the table-like structure where I can understand this data. This one. What is this information? In the 1949, in the month of January, 112 passengers boarded in any plane. It could be, doesn't matter. In 1952, 171 number of passengers moved in month of January. In 1956, 284 number of passengers moved in month of January. In 1960, 417 number of passengers moved into January. They boarded the flight. So what is this? With number of increase in years, correspondingly passenger numbers are also increasing. The same is happening if I'm taking in March month of 1951, 178 passengers boarded. 267 people boarded in 1955 in the month of March, and here it is 406 and 490. Again, the number of passengers are increasing with increasing number of year. The same is happening in the April, September. So you can see in August 148 to it is moving 606. So the point is that with increased number of year, the number of passengers are increasing. So the point is here now that if you see this data, see, just by looking this data set now, it is not very much accessible or very much informative. Means I'm not able to understand much this data set. Though if I see this figure, from this figure, I can understand that in May, June, July, summer season, maximum number of travelings are increased. But I want to understand it with the help of graph. For that, there is a heat map. Heat map is one of the graphs where we can understand the data well. Now, how I can interpret this heat map? You can see here, when we are moving towards this side, dark color to light color, that shows the positive relation is present into the data set. When we move from this to this darker side, this shows negative relation is present into the data set. If you see this black color here, black shades, that shows negative data that shows the number of passengers are very less in these years and this month. And when you see the increasing, see this light color shade, students focus here, light color shade. If we are moving towards the light color shade, these light color shade, we are moving towards, we are increasing towards light color shade. So that shows the number of passengers are increasing with the increasing number of years. Okay, so positivity into the data, negative into the data. Positive number of people are increasing into the flight, negative people are negative, people are not increasing. So whenever darker zone you are getting, that shows the data's very less people are moving into the flight. But you see this lighter side, light shade data that shows you increasing number of the passengers into the flight. So if you see this data, what it shows you, you can say this side, this whitish side also. That shows you here that shows you here. See, student, this white shade. See this white shade. That shows you that in the month of May, June, July. See this one. That in the month of May, June, July, the number of passengers are increasing. So nearby, after 1955, the change comes and the number of passengers starts increasing, and maximum number of people we are able to find it out here in the month of July, August. Means here May, June, July, August, because summer seasons are there, so people travelings are much more higher it is there. Got the point here? So this information we are dragging it out from here. So students, remember, heat map is one of the map which shows us the difference. Basically, it is showing us the correlation between the data. It is showing us the correlation between the data. So the lighter side, the color which is moving towards the lighter side, that shows the positive correlation, and here the negative correlation. So all the darker color here, it is just showing you that negative correlations are there, means in these year or these months, very few people traveled. But here in the month of May, June, July, August, the number of passengers are increased with increased number of year. So that is overall for the seaborne. Okay. So that is overall for the seaborne. Thank you very much, students. Thank you. Thank you very much. Have you understood well now? You can see the video again. Thanks. Thank you. This is heat map here.